Hello, today we will be using physics to determine the fastest possible speed of this object on 3 separate ramps. We will do this by using 3 formulas. The first being the sine theta equals opposite side over hypotenuse, which utilizes the easily measured height and distance of a ramp to determine the angle of the ramp. Second, we will use the acceleration equals g sine theta formula to determine the acceleration with the angle and the constant 9.8 meters over seconds represented by the g. Finally, we will use the formula change in time equals square root of 2 times the change in x divided by acceleration t that can be used to find the time it takes the object to get down the ramp.
All right, for our first ramp, we have a ramp that is 15.5 centimeters tall and 41 with all these numbers length and width, a ramp that is 44.5 centimeters in length. Obviously, we will convert to meters when necessary. So, that's it next. So we start with this first formula, and that requires us to take the sine negative, and then, of course I did that, and then we take the 15.5 divided by the 41.7133, so on and so forth. And by doing that, we get 20.38426 degrees. And that is the degree of our angle. And using that, we are now able to find our acceleration. So we take 9.8 sine, and I'm not going to rewrite the entire angle, so we'll just put that there. And this results in us getting 3.413486 meters per second squared. Now, with the acceleration determined, we can now use the change in time formula, and that will require us to take the square root of 2 times the change in x over the acceleration. And I'm not going to rewrite them because I've already shown them, but when we calculate that, we get 1.49437 seconds. So the length of time it will take for this guy to get to the bottom of the ramp is these many seconds.
We now know that the fastest possible speed on this ramp is this, and if we look at the experiment played out, we can see that this car gets very close to the maximum speed.
This is our second ramp that we will be using, and its dimensions are listed below. And here we have our last ramp that we will be using. Again, its dimensions are listed below. And here we have the final results for all 3 of the ramps experimented on. As you can see, our predicted time was very close to the actual time, showing how this calculation is pretty accurate.